Hi everybody, it's Mrs. Peachy from your physics class at WCA, and I am going to briefly be going through the Momentum Lab from Unit 4, Lesson 7 for your physics class. What starts off as kind of different for this portfolio is that it does not ask you to do a hypothetical experiment. So normally, the first part of your lab would be for you to write up a hypothetical experiment of what you would do to test this principle in an actual hands-on setting. In this case, it does not ask you to do that, so that part you can skip. You are going to start off with developing your hypothesis, and think about your hypothesis as we're looking at whether or not momentum is conserved in both elastic and inelastic collisions. So basically, how would the momentum of the ball compare before and after the collision? And how would total momentum kind of compare? And would that be conserved in an inelastic collision? Would it be conserved in an elastic collision? Would there be any differences? It also says support your hypothesis with knowledge of momentum. And I've been telling you that all along, and that's something that I have been looking for, is that when you make your hypothesis, that you should be supporting it with information from your reading. So if you believe, yes, that momentum should be conserved, then you need to make sure you put some information in there from the text that supports what you're saying. If you think that it's only going to be conserved in elastic collisions and not inelastic collisions, then you should also, put something in there that supports that from the text, just depending on whatever your hypothesis is. But you should always have text-based evidence as part of your support. This is going to use a simulation from PhET. It's from the University of Colorado. They have all of these physical science simulations, and you're going to need to make up a couple of different data tables. I'm trying to get this kind of bigger for you here, but it isn't letting me change the size of the box here. So the two data tables in your spreadsheet, you are going to have a data table for elastic collisions and a second data table for inelastic collisions. And then you're also going to be doing some calculations afterwards to show me whether or not momentum is conserved. Remember, momentum takes into consideration the mass of the objects times their velocity. Remember, too, that velocity is a vector, so it has directional quality to it. So when you are doing the math involved, you have to use the positive and negative signs to indicate direction. Which direction is positive and which direction is negative is really just completely arbitrary. You can decide that on your own. You can make to the right be positive and to the left be negative, or vice versa, as long as you are consistent and use the same directional indicator for all of your work. Okay? So there are things that are done by convention. I would say I would probably make right positive and left negative because that's how we see it on a Cartesian coordinate system. But it really doesn't matter which way you do it, as so long as one direction's positive, the other direction's negative, and you are consistent throughout. So I would like to go to the Collision Lab website now. I'm going to bring that up for you here. So this is our sim, and you can kind of see it in the middle here. You can change things. You can change the size of the masses. You can change the directions or the speed here. This sim speed here, by the way, is just how fast the sim runs. So, if I want to make it real slow, I want to speed it up. Let's restart it. The sim just runs quicker, right? Okay, so the balls are moving quicker is basically what's happening there. You can also change the quality of the collision from elastic to inelastic. So this is an entirely elastic collision, and then you can make it an entirely inelastic collision or somewhere in between. You can show certain vectors. You can show momentum vectors. It's just going to tell you, where the momentum is going. It also, remember that a vector on here will not just be a direction, but it'll also give you a size of the arrow, which will indicate kind of relative size, relative quantity, right? So if you're looking at velocity, for example, the larger the arrow, the faster it's going, but it's not going to give you the numeric value. Okay, so according to your lab, it says you are going to first look at the elastic collisions, and it says start with the following settings. It gives you 0.5 kilograms. I'm just going to put this back here. 0.5 kilograms for mass 1. Mass 2 should also be 0.5 kilograms. You can just type that right in. And velocity 1, oh, there we go. Sorry, I couldn't find that at first. You have to hit more data. Velocity 1 is going to be 0.2 meters per second. And it gives you make sure you put the sign in like I'm saying, but that's a positive 0.2. And velocity 2 is 0 meters per second. Oops. My bad. Let's try this one more time. Okay, this one's 0. All right. So you record these values in your data table, and then we can go ahead and we can observe the sim. Let me get my picture out of the way here. Excuse me. You have to let them collide. Once the collision takes place, you can then look at the final velocities of them. And as you can see from this, they just flip-flop their velocities, right? All right, so that's kind of what you're doing for this one. I'm not going to go through all of the numbers because you're going to need to do several other collisions. Inelastic collisions, you're going to do the same thing, but you're going to slide the slider over here all the way to inelastic. Use the same initial conditions and record them. Then you need to find the momentum. And when you find momentum, remember that's mass times velocity. Mass should be in kilograms, velocity should be in meters per second. So you're going to find the momentum of both of the balls added together before the collision and both of them added together after the collision. So you have to find the momentum of the individual balls before and the individual ones after, but make sure you sum them together because total momentum, conservation of momentum deals with the conservation of total momentum before and after, not the conservation of momentum of the individual objects within the system. So we're looking at the whole system, not just individual objects. Remember to show your math for that portion. If you're doing calculations, I always need to see them. I can't just see the final product. Okay, and finally, you get the drawing conclusion section. Okay, and this is what you will put in the conclusion portion of your lab report. If you could please make sure that you type out the actual conclusion question, and then in a different color, write out your answer. Don't forget to support it with evidence from your text, and also remember that you will also be reflecting back on your hypothesis for this. So this portfolio is pretty straightforward. So the tutorial is pretty much just standard. There's not a lot to learn here. So if you do have questions or concerns, however, if there's something I didn't go over that you didn't quite get, give me a call at extension 2204, or you can send me a webmail message. Good luck on your physics portfolio, and have a great day.